Today, we're going to look at the Algebra 2 Edgenuity Section 6.6, Properties of Logarithms. The objective for this section is to evaluate, expand, and simplify logarithmic expressions using properties of logarithms. So we are going to talk a lot about the properties of logarithms today. Let's look at our first problem. We want to expand this, which reads log base 4 of 12, to evaluate it given that log base 4 of 3 is approximately equal to 0.792. Now, we say approximately equal to because logarithms, for the most part, unless they come out real nice and clean, logarithms are irrational numbers, usually. So that's why we have to give some rounded decimal approximation. In this case, we happen to be doing it to 3 decimal places. So what we're going to use for that is this cool little fact right here, that if you have the log of 2 things multiplied together, then that expands into the log of the 2 things separately added together. So that's what that fact there says. It says log base b of x times y together is equal to log base b of x plus log base b of y. And those bases have to be the same. So here's what you would do. Here's how you would use this to help you, okay? We would say log base 4 of, and instead of saying 12, what we're going to say is, let's use 3 times something is 12. Well, that's 3 times 4. And it's going to turn out that this is going to give us everything we need. And what I'm going to do is I'm just going to follow the identity right above it. That means that log base 4 of 3 plus log base 4 of 4 is the same thing as log base 4 of 3 times 4. So we have a decimal approximation for log base 4 of 3. It's 0.792. Plus, and then let's explore over here what log base 4 of 4 is. Let's set it equal to n, and let's rewrite it in exponent form. So that would be the base, which you see right there, raised to this, so 4 to the n power is equal to that right there. So is equal to 4. And 4 is 4 to the first. And if you remember from a previous section, once we have the same bases, we can ignore them and set the exponents equal to each other. And this n is this n, so log base 4 of 4 is equal to 1. So I'll put a 1 right there. And then this decimal plus 1 is 1.792. And there we have our answer, although really I should, instead of writing equals, I should have been writing approximately equal to, because that decimal part is an approximation. The 1 is completely accurate, but the decimal part is just a rounded decimal approximation. I'll pause for a moment, let you look at this, see if there are questions. Okay, there being no questions, I'll move on to the next problem. So now let's talk about expanding something, or condensing something a little bit more. So here's a thing, and let's talk about writing it as a single log, as a single logarithm. It helps us out that the bases are the same. Otherwise, this is a really, really difficult problem. And so what we're going to do is we're going to say, okay, we've got those two multiply. We may as well just multiply them together. I maybe could think about taking them apart, but I'm trying to put everything together, so I may as well put things together as I go for right now. So that's log base 7 of 12 plus log base 7 of 3. And then if I'm adding these two, I can condense them, shrink them, into one logarithm, base 7, and all I have to do is put them together, and it condenses into multiplication. And then I just multiply the numbers together. Log base 7 of 12 times 3, which is 36. And there is my answer. I'll pause for a moment, let you look at this, see if there are questions. Okay, there being no questions, I'll move on. Let's talk about expanding this one. We've got 3 multiplications going on. So let's isolate it into 2 parts first, and then we'll expand beyond that. So log base h of 9j, we'll sort of think of that as one thing for the moment, and times k, and we expand multiplication into addition, so this would become log base h of k. Then I can expand this multiplication into addition also. So log base h of 9 plus log base h of j plus log base h of k. And there we have it. We have expanded it out as far as we can expand it. I'll pause for a moment to see if there are questions. There being no questions, I'll move on. All right, so if I'm given 2 approximations here, log base 6 of 30 and log base 6 of 2, and I'm asked to evaluate the log base 6 of 15, I'm going to use this property right here, which says you can expand division into subtraction. And that actually comes from the fact that division is a form of multiplication, and maybe I can show that at the end. We'll see. So we've got log base b, whatever b is, doesn't matter, or I'm sorry, not b, 6. Log base 6. These are all, those are all 6s there. I should fix that. Let me make it a lot clearer. They look like b's. Let me make it a lot clearer that those are 6s. Base 6. Base 6. Base 6. There we go. That's a little better. So log base 6 of 15. 15 is 30 divided by 2, and I think you can probably already see where this is going. So that would be log base 6 of 30 minus log base 6 of 2, and I have decimal approximations for each one of those. Log base 6 of 30 is approximately, let me be careful about that, is approximately 1.898, and log base 6 of 2 is approximately 0.387, and then maybe I'll do a little bit of side work over here and do 1.898 minus 0.387, and that'll be a 1, that'll be a 1, that'll be a 5, that'll be a 1. So it's approximately 1.511. And there we have it. All right. So now we've used yet another logarithmic property, and this is the division property. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. Now we want to condense. So I've got this, and the minus means it'll condense into division. So log base 14 of the first thing divided by the second thing. And then it might be helpful to turn this division problem into multiplication by reciprocal. So log base 14 of, well, when we do that, we keep the top, change the division to multiplication, and flip the bottom. So that becomes 6 times 2 over 3. And then when you multiply fractions by not fractions, you multiply to the top. So this is 6 times 2 is 12 over 3. And then 12 divided by 3 is 4. So log base 14 of 4 becomes our final answer. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. Now let's expand one with all variables actually. This division expands into subtraction, so this will be log base W of x minus log base W of z. And that's it. That's all we can do with that. So that is our answer right there. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. All right, so now we want to write an expression equivalent to log base 3 of 8 using this property here, that if you have an exponent inside the log, you can bring it out to the front as multiplication. So if I have log base 3 of 8, I might want to note that 8 is 2 to the third power. So instead of writing log base 3 of 8, I might write log base 3 of 2 to the third, and then take this 3 and bring it out to the front as multiplication. So then it would be that 3 times log base 3 of 2, and that would be my answer. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. All right, so now let's use that knowledge and an approximation for log base 3 of 2 to evaluate log base 3 of 8. So log base 3 of 8, as we noted, was log base 3 of 2 to the third, which was 3 times log base 3 of 2, which is approximately 3 times 0.631. I'm using that approximation right there. And then I'll do some side work maybe and figure this out. 0.631 times 3 is 3, 9, 18, 3 decimal places. So this is approximately 1.893. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. So let's rewrite this and see what we can do with it. So if I use the exponent rule, the power rule, that'll be 9 times log base 3 of x. And there's really nothing else I can do here, so that becomes my answer. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. Let's talk about how we might expand this problem. So we've got multiplication between those two and division here. So let's do this first. Let's look at the multiplication. And let's say that'll be log base 5 of 8 plus log base 5 of the square root of t over v. Then we'll talk about how we deal with the square root probably at the end. So that's log base 5 of 8. We could do 2 to the third, but it's okay to leave it like that too. Plus, well, no, you know what? Let's call it 2 to the third. That way we can get a full expansion. Okay? Plus log base 5 of the square root of t minus log base 5 of v. So now we've done all of the changing multiplication and division into addition and subtraction. Now we need the power rule for this, and we got to figure out what we're going to do with that. So so I'll bring that 3 out to the front, and it'll be 3 times log base 5 of 2 plus log base 5 of the square root of t is actually a power of t. It is t to the 1/2 power. And so we'll be able to use the power rule there also. Minus log base 5 of v. So that's 3 times log base 5 of 2 plus, we'll use the power rule on this, bring it out to the front like that. And that'll be 1/2 times log base 5 of t minus log base 5 of v. And so this is a completely expanded form of that. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. All right, and now we're going to use common log. Remember, common log is log base 10. And we want to write this as a single log. So we want to compress it, compact it as much as possible. So I see that. I also see this multiplication. What I'm going to do is I'm going to move this first. Okay? I'm going to turn that into a power. So log base, or not base 9, common log of 9, that is log base 10 of 9, minus common log of k to the second power. So that's our first compression, our first way of writing it more compact. And then I've got subtraction, which condenses into division. So this is the common log of a division problem, 9 over k squared. And there we have it written as a single log in the most compact form that we can get it. I'll pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. 2 notes that might help you. At some point, they give you the proof for the product property. Write that down. Also, it's important to note that you can't use the property that you're trying to prove in a proof of that property. I couldn't use the product property within the proof for the product property. So, 2 things that might be good to keep in mind. Thank you so much. This is the end of this section.